Today we will be looking at 4.2, which is dealing with exponential functions. So, an exponential function can be stated if a is greater than 0 and a is not equal to 1, then the exponential function with base a is f of x is equal to a raised to the x. So, some additional properties of exponents. First, for any real number a greater than 0 and a is not equal to 1, we have 4 of these different types of properties. So for our first one, a raised to the x is a unique real number for all real numbers x. Our second part, a raised to the b is equal to a raised to the c if and only if b is equal to c. So again, here are exponents here. We have b and c, and if we have a, which is the same number, they're going to be equal if and only if b is equal to c. Now, for our part 3, if a is greater than 1 and m is less than n, then a raised to the m is less than a raised to the n. And our last one here, if a is between 0 and 1 and m is less than n, then a raised to the m is going to be greater than a raised to the n. So, let's go ahead and look at some examples here of evaluating exponential functions. So, the problem states, for f of x equal to 4 raised to the x, find each of the following. So our first one we want to go ahead and evaluate is f of negative 2. So all we really need to do is plug in that negative 2 into our function every single time we see x. So f of negative 2 is going to get me 4 raised to the negative 2. Another way we could write this, since we're dealing with negative exponents, is 1 divided by and then 4 squared, which will give me 1/16. Okay, let's go ahead and look at f of 5 and go ahead and try to evaluate it. So, same thing, we're going to go ahead and take our 5 and plug it into our function every single time we see an x. So that will get me 4 raised to the 5th, or 1024. Okay, so now we want to go ahead and evaluate this 2/3. So again, every single time we see an x, we're going to go ahead and replace it with this 2/3 here. So that will get me 4 raised to the 2/3. And another way that we can write this is that the top number is what we raise it to, and the bottom is going to be our radical here. So we can rewrite this by saying the cubed root of 4 and then go ahead and take that quantity and square it. So that should get us approximately 2.52. Okay, so now we have d. We want to go ahead and evaluate this 2.15 into our function. So again, every single time we see an x, we want to go ahead and replace it with this 2.15. So that should get us a 4 raised to the 2.15, or in other words, 19.698. Okay. So next we can go ahead and start looking at these exponential functions now that we have looked at a couple of examples of evaluating. So for our first example, we want to go ahead and try to graph our exponential function here of 2 raised to the x. So with all these graphs, the best thing to do is go ahead and pick some points and figure out what it's going to look like on your graph. So starting with 0, if we plug in a 0, 2 raised to the 0 is going to get me a 1. Now, if I do a negative 1, 2 raised to the negative 1 is the same thing as saying 1 divided by 2, so 1/2. Next, if we pick, say, negative 2, a positive 1, and then a positive 2, we will get values of 1/4. We will get values of 2, and then finally a value of a 4 if we plug in the 2. So let's go ahead and graph this and figure out what it looks like. So starting with the point of 0, 1, we will have a point on our y-axis here. Additionally, we have the point of 1, 2, so 1 and then 2. We'll have another point up here. And last, we will have a point at 2, 4. So 2, 4. That will be a point all the way up here. And then we have a point at -1, 1/2, and a point at -2, 1/4. So we should have 2 additional points on this left-hand side that look like this. So connecting our dots here, we should get some sort of function that looks like this. Okay. So next we can go ahead and move on to our f of x is equal to 1/2 raised to the x. Let's go ahead and figure out what this one looks like. So again, we want to go ahead and plug in some points here to see what our general graph is going to look like. So starting with 0, we should get a value of 1 because 1/2 to the 0 will get me a 1. If I plug in a 1, that will get me 1/2 to the 1, or in other words, 1/2. If I plug in a -1, that will get me 1 divided by 1/2, or 2. And finally, if I plug in a -2, I should get a 4. And then if I plug in a +2, I should get a 1/4. So this one is basically going to look like our previous graph, except it's going to be reflected over our y-axis. So starting with that point of 0, 1, we should have a point right here. Then additionally, we have a point of -1, 2. So -1 and then 2. We have a point up here. Then we have -2 and then all the way at 4. So again, we have a point over here on our left-hand side. Then we have a point at 1, 1/2. And our last point here is going to be 2, 1/4. So connecting our lines here, we should get some sort of graph that looks like this. So again, this looks very similar to the graph above. It was just reflected over our y-axis here. So that leads us into our next topic here, which is the characteristics of the graph of f of x is equal to a raised to the x. So for our first point here, the points of -1 and then 1 divided by a, also 0, 1, and then 1a are on the graph, right? We saw that with our first and our second example here. We have our points 0, 1, and additionally, if we look back, we have points of -1 and then 1 divided by a. So -1 and then 1 divided by a would get us that, and then etc. we would have that as well. So point 2, it tells us that if a is greater than 1, then the graph is an increasing function, and if our a is between 0 and 1, then we are a decreasing function. So again, if we go ahead and look back up, if a is greater than 1, we are an increasing function, right? We saw that our a was, in this case, a 2, which is greater than 1. So again, we're going to be increasing. And in our second example, we saw that we were between 0 and 1. So this will be a decreasing function. Okay, so we have 2 more points here. We have point 3. So the x-axis is a horizontal asymptote. And finally, the domain is -infinity to infinity, and the range is 0 to infinity. So that x-axis is going to act as a horizontal asymptote, which means that our graph is going to get very close but not quite touch it. Okay, so our next topic, we looked at some of our basic graphs. What we can actually do now is perform some reflections and translations. So say, for example, we are looking at f of x is equal to -3 raised to the x. Let's go ahead and figure out what this one is going to look like. So again, we're going to go ahead and start off by plotting some points here. So starting with a 0, if I plug in a 0, I will get a -1. If I plug in a -1, I should get approximately a -1/3. And then if I plug in a +1, I should get a -3, and so on. So this should be enough to get some sort of general idea of what our graph is going to look like. So 0, -1, -1, and then -1/3. So that should be approximately right here. And then last we have positive 1 all the way down at negative 3. So connecting our lines, we should get some sort of graph that looks like this. Okay, again, our x-axis is going to act as a horizontal asymptote, so we're going to get really close to it but not quite touch it. Additionally, we can go ahead and look at 3 raised to the x minus 2. So what does this 2 tell us? So it's going to tell us something that we've kind of looked at in the past. So this is actually going to tell us that we are going to move to the right 2. So right 2. Okay, so again, let's go ahead and pick some points to figure out what this one is going to look like. So if I start with a 0 here, I'm actually going to get 3 raised to the 0 minus 2, or in other words, in this case, 1/9. If I pick a positive 1, I will get a 1/3. If I pick a 2, again, that's going to be 3 raised to the 2 minus 2, or a 1. And then a last point of 3. If I plug in a 3, I'll get 3 raised to the 3 minus 2, or a positive 3. So let's go ahead and plot these points and figure out what this is going to look like. So our first point of 0 and then 1/9, that's going to be a point approximately right here. A point of 1 and then a positive 1/3 approximately right there. And additionally, we have a 2, 1, and our last point is going to be this 3, 3. So that is going to be all the way up here. So connecting our points, we should get some sort of graph that looks like this. And we should be good to go for that one. So our last part here is going to be C, looking at a combination of different types of translations. So let's go ahead and pick out our pieces of information. So first one, x plus 2, and then finally this minus 2 tacked on to the end. So that x plus 2 is going to tell us that we are actually moving to the left 2, so left 2. And additionally, this negative 2 tells us that we move down 2. So let's go ahead and try to plot some points given this new information here. So if I plug in a 0 is going to get me a 3 raised to the 0 plus 2, or 3 raised to the 2, which is 9, and then minus 2 gives me a 7. Now if I pick a negative 1, this will get me 3 raised to the negative 1 plus 2, or 3 minus 2. So that will get me a positive 1. And then last, if I pick a negative 2, that should get me a 3 raised to the negative 2 plus 2, or 0. So that would give me a 1 minus a 2, or a negative 1. And we should be good to go to figure out what this is going to look like. So our first point here is at 0 and then positive 7. So 1, 2, 3, 4, 5, 6, 7. We have a point right there. Then we have a point at negative 1, 1. And last we have a point at negative 2, negative 1. So connecting our dots here, we should get some sort of graph that looks like this. So okay, so this is what our graph looks like. And again, we shifted to the left 2, and then we shifted down 2 as well. So we should be good to go for part C here. Okay, so next we're going to go ahead and look at solving some of these exponential functions. We looked at graphing them, but sometimes we need to solve for x within an exponential function. So let's go ahead and go through some steps in order to find out what this x is. So our problem says solve 5 raised to the x, and it's going to be equal to 1 divided by 125. So our first step is going to be step 1. Step 1, what we want to do is get each side to a common base. So okay, so first step, we want to go ahead and get each side of the equation to some sort of common base. So let's go ahead and figure out how we can rewrite this. So we can rewrite 1 divided by 125 as, so 1 divided by 125 can be rewritten with a negative exponent. So 125 to the negative 1. So what are we left with after we've rewritten our number here? Well, that gives us 5 raised to the x is now equal to 125 to the negative 1. So essentially what we want to do is get each side to a common base. So really what we want to do is get that big number down to a smaller number. So in other words, we want to go ahead and try to get a common base of a 5. So we can ask ourselves, 5 raised to what gets us this 125 here. So we need to stop and think, 5 raised to what is going to get us this 125? Well, 5 raised to the 3 is actually going to get us this 125. So we can go ahead and rewrite. We still have this 5x. That's going to equal 5 raised to the 3 because that gets us the 125. And then finally, we still have to the negative 1. So we can now move on to step number 2. So with step number 2, what we want to do is set our exponents equal to each other because of our property B. So step 2, set exponents equal to each other. And this is because of our property B. So let's go ahead and take a look back up at our properties here. So with our property B here, if we go all the way back up to the top, it says that we have a raised to the b is equal to a raised to the c if and only if b is equal to c. So what this allows us to do is if we have our same bases, we can now go ahead and set our exponents equal to each other. So let's go ahead and look back at our example here. So looking back at our example, what we can now do is, since we are dealing with a base of 5 and then a base of 5, we can set our exponents equal to each other. So our resulting exponents, what do we have? Well, in this case, we will have this positive x here, and then we have to take care of the positive 3 times the negative 1. So that will get me an x is equal to a 3 times a negative 1, or in our case, an x is equal to a negative 3. So that should complete this problem. The biggest thing is that you want to go ahead and try to get your bases to be the same. Try to get your larger number down to your smaller base if possible. So let's go ahead and look at another example here, a little bit more complex. So we are now dealing with 3 raised to the x plus 1, and it's equal to 9 raised to the x minus 3. So again, we want to go ahead and try to get each side with a common base. So we need to get common base. So let's go ahead and try to get a common base. We want to go ahead and try to get that 9 down to a base of 3. So we will still have a 3 raised to the x plus 1, and that's going to be equal to, we want 3 raised to something to get us a 9. 3 raised to what gets us a 9? 3 raised to a 2 gets us the 9. And we still need to take care of the exponents that we still had, which was x minus 3. Now, again, using that property B, what can we do? We can go ahead and set our exponents of x plus 1 and then 2 times x minus 3 equal to each other. So that will give us an x plus 1 is equal to a 2 times an x minus 3, Or in other words, x plus 1 is equal to 2x minus a6. And all we need to do is solve for x now. So solve for x. What's that going to get us? Well, we can go ahead and subtract the 2x over to one side. So let's go ahead and subtract the 2x, subtract 2x. That will now get us a negative x. And then we can go ahead and subtract that negative 1 over to our right hand side. So in other words, this will get us negative 7 on our right hand side. So we have a negative x is equal to a negative 7. So we can go ahead and divide by negative 1. So x is going to be equal to a positive 7. Okay, so we have one more example. And this is going to be solving with fractional exponents. So say, for example, we are given x raised to the 2 divided by 3, and it's equal to 25. So again, what we want to do is go ahead and try to rewrite our x raised to the 2/3 to see if it will come out to something that's a little bit easier to work with. So this is going to give us, in this case, an x, and we can go ahead and take our top portion here, which is going to be this 2, and this is what we're going to be raising it to, and then the bottom is going to be associated with our radical here. So that's going to be that 3 there. So how can we rewrite this? Well, it's going to be the cubed root, right? Because our bottom number is associated with our radical. And then we can go ahead and take that quantity and square it, which is going to be that top number. And that's going to be equal to a 25. Now, all we need to do is go ahead and try to simplify this into x. So let's go ahead and see what we can do here. We know that we're dealing with a square here. So in order to get rid of the square, we can go ahead and take the square root of both sides. So that will get us the cubed root of x is equal to, and if you recall, whenever we take the square root, we want to go ahead and add that symbol of plus or minus, and the square root of 25 is going to get me a positive 5. So the last step we want to do is go ahead and try to get rid of that cubed root. So let's go ahead and figure out what we can do in order to get rid of this cubed root. Well, in order to get rid of a cubed root, we can go ahead and raise each side to the 3rd. So that's going to give us x is equal to a plus or minus, and 5 raised to the 3rd gets me a 125. So we have x is equal to positive 125, or x is equal to negative 125. Okay, so next we can go ahead and move on to our compound interest formula. So our compound interest formula, it's going to state a is equal to p times 1 plus r divided by n, and then it's going to raise that quantity to the t times n. So if you look at these different types of color coding, our a is going to represent our dollars in our account after some sort of time period. Our p is going to be our dollars deposited. Our r is going to be our rate of interest. Our n is going to be our times compounded per year. Now, if it tells us that it is semi-annually, that's going to give us a value of n is equal to 2. And then quarterly, if it tells us that, then our n is going to give a value of a 4. Last, we have our t, which is going to be our years. So, using our compound interest formula, our problem states, suppose $2,500 is deposited into an account paying 3% per year. So our first pieces of information is going to be this $2,500 and then this 3% per year. And then our last portion that it tells us is that it was compounded semi-annually. So part A asks us to find the amount in the account after 10 years. So that is going to be our last piece of information here. So what do we want to do? Well, first let's go ahead and write out the information that we know. So for part A, we know that our P, which is equal to our amount initially deposited, is going to be 2,500. What else do we know? We know that our R is going to be equal to 3%. Again, we want to go ahead and convert the decimals. So that's going to give us a 0.03. We need to be super careful with what kind of interest rate we're plugging in here. Now, our n, it tells us, is going to be equal to what? Well, it told us that it was semi-annually, so in other words, a 2. And then a t is going to be equal to, it told us 10 years, so t is equal to 10. And essentially we are solving for our a here. So all we need to do is go ahead and plug this information into our formula to figure out what our a is going to be. So a is going to be equal to 2,500, and then 1 plus, it was r divided by n, so 0.03, divided by, and then our n was 2, raised to, and then the n times t, so that's going to give us a 10 times a 2. Okay, so if we go ahead and plug that into our calculator, we should get a value of $3,367.14, which makes sense because we have some sort of interest. If we got some sort of value that's lower than 2,500, then we would need to go ahead and look at our calculations to make sure we did everything correctly. Now, B asks us how much interest is earned over the 10-year period. So, in order to answer this question, we know that our dollar amount after 10 years was this $3367.14. So in order to find out how much interest we earned over the 10-year period, we can go ahead and take this amount after the 10 years and then subtract what we initially put into our account. So let's go ahead and look at part B here. So part B, we can go ahead and take our amount that we ended after 10 years. So that was this 3367.14, and then subtract what we initially put in, and this should give us the amount that we earned in interest. So that actually turns out to be $867.14, and we should be finished for part B there. So what do we have next? Well, we have finding our present value. So we have Brendan, and he must pay a lump sum of $15,000 in 8 years. What we want to find out is what amount deposited today, or present value, at 2.4% compounded annually will give us $15,000 in 8 years. So let's go ahead and figure out what we need to do here. So we know that our A is equal to, now it's going to be given to us. It's going to be this $15,000 here. So we have the $15,000. It is compounded annually and will give us this amount in 8 years. Let's go ahead and use the 2.4 as well. So A is going to be equal to 15,000. We want to find our present value, or the amount deposited. We are given an R, or interest rate, of 2.4, so that's going to be 0.024. Our time is equal to 8, and then it told us annually, so in this case our n is going to be equal to a 1. So using our formula, what we have is the A is equal to P times the 1 plus R divided by N times NT. So let's go ahead and plug in our information here. So 15,000 is going to be equal to RP is what we want to find, 1 plus, in this case, a 0.024 divided by a 1, and then finally raised to the NT, or in this case, an 8 times a 1. So if we go ahead and try to do some computations on this to simplify it, let's see what we get. So we still have the 15,000, and that's going to be equal to a P times, and this middle portion here is actually going to simplify. So we can go ahead and simplify this, and that turns out to be 1.024 raised to the 8. So we can go ahead and take that value and divide it out in order to find our P. So 1.024 24 raised to the 8 and divide it onto our left-hand side. And that should get us a present value or amount that we need to deposit as $12,407.71. So we can move on to part B here. It states if only $12,025 is available to deposit now, what annual interest rate is needed for the money to increase to $15,000 in 8 years? So let's go ahead and write the information that we know. So again, we know that our A is going to be equal to $15,000. We know that our P now is going to be equal to, what did it tell us? It told us $12,025. So $12,025. We know that our R is going to be equal to something. We need to figure out what it is. And then finally, our T is equal to 8 because it states 8 years. And last, we know that our N is equal to 1 because it told us annually. So let's go ahead and plug our information in and solve for that R. So again, A is equal to P times 1 plus R divided by N times NT. So we'll have $15,000, and that's going to be equal to our P, which is 12,025. And this is going to be multiplied by 1 plus R divided by, and our N was 1, raised to the 8 times 1, or NT. So, okay. So first things first, we want to go ahead and try to divide that 12,025 out. So dividing the 12,025 out, we should get a value of, and we're going to go ahead and keep that fraction on the left hand side. So 12,025 also. Okay, so we are left with on our right hand side a 1 plus R divided by 1, which is just going to be R in this case, and that is going to be raised to the 8th power. So in order to get rid of the 8th power, we can go ahead and take the 8th root of our left hand side. So let's go ahead and do so. Okay, so taking the 8th root of our left hand side, we are left with the result, and this should give us 15,000 divided by 12,025. And another way we can rewrite the 8th root is 1 divided by 8, and that's going to be our power here. So that is going to be equal to 1 plus R. So all we need to do in order to solve for R is go ahead and subtract that 1 off. So subtracting the 1 off, we are left with R is equal to 15,000 divided by the 12,025 to the 1/8 power, and then finally minus a 1. So that should give us an approximate rate of 0.028, or we could say 2.8% as our interest rate. Okay, so just to summarize, in order for us to have $15,000, given that we only deposited $12,025, we would need a rate of, in this case, 2.8% in order for us to hit that money in 8 years. So additionally, we have the value of E. So the value of E can be approximated by 2.718281828, and what we can essentially do is the graph of 1 plus 1 divided by n to the n. It basically approaches E as we increase without any bound. So if we go ahead and look at our formula there, A is equal to P times 1 plus R divided by n to the Tn. Essentially, written in blue here, what we have, that is going to approach E. So we can go ahead and make a replacement for the portion highlighted in blue with E, when we are dealing with no bounds. So this is actually going to be our continuous compounding formula. So the key word is if it tells you compounded continuously, you're going to want to go ahead and use the a is equal to p times e raised to the rt formula. Now, if it tells you some sort of time period, then in that case, you'd want to go ahead and use the a is equal to p times 1 plus r divided by n to the tn. So that is going to be our continuous compounding formula. Let's go ahead and look at an example using it. So using the continuous compounding formula, suppose $8,000 is deposited into an account paying 5%. So $8,000 paying 5% interest, and it is compounded continuously. That is going to be a key word for 6 years. Find the amount after 6 years. That is going to be our question here. So let's go ahead and write the information that we know. We want to find A, and then P is going to be equal to our amount that we initially deposited, or $8,000. And then finally our R and our T, let's go ahead and find those. Our R is equal to 5%, or 0.05. And then our T is our time, which is equal to a 6. So using our formula, A is equal to P e to the RT. That is going to give us A is equal to $8,000, and then we have E raised to the 0.05, and then multiplied by a 6. So if we do the calculations in our calculator, we should get A is equal to the dollar amount of $10,798.87.